Okay, thank you all for coming to my talk. So the first question you might have is, why is this titled Dependency Injection quickly? Earlier this year, I actually got the opportunity to go to Cleveland and give a talk at PyCon on mocking and patching pitfalls, or mock hell. And one of the ideas from that talk was that you should consider using dependency injection instead of patching for your unit test. So this talk is kind of a continuation or a sequel to that one. One of the outcomes from giving that talk was I got to have a lot of conversations with other developers and learn a bunch of things. And one of the things I learned is that dependency injection is actually, I think, a somewhat foreign idea within the Python community, probably because there's such diversity of backgrounds to people who use Python. So what happens when people first encounter it is that it can be really unintuitive, especially if you don't have an object-oriented background. It's less common in Python than it is in other languages like Java, C#, and C++. And the consequence is that it can be subject to a bunch of misunderstandings or misapplications. So people see it, it looks complicated, so they just resort to patching, or they try it and they have a bad experience and get burned. Despite that, you're going to see dependency injection come up in a variety of libraries and frameworks and APIs. You're also going to run into developers who really hate dependency injection, and some people are going to really like it. So one way or the other, it's good to know about it because you're probably going to encounter it at some point or another. Why quickly? So if you go and search for information about dependency injection, because you want to learn about it, most of the examples are actually going to be in things like Java, C#, or C++. And you run into a lot of jargon and sort of kind of dense information that relies on knowing a lot about object-oriented design. So you'll see all these kind of terms that are thrown around. I think in Python that these things are not actually essential. Because in Python, you have duck typing, and a lot of these patterns or terms come out of limitations that exist in other statically compiled languages. So I think it's actually much simpler to explain dependency injection in Python. And the way I actually like to think about it is a little bit backwards. I like to think about it in terms of dependency extraction. And so basically the rest of this talk is going to be kind of a pair programming exercise where I start with some code that's written in an imperative style and is a little bit dirty. I'm going to refactor it towards something that's cleaner by extracting dependencies and then applying dependency injection to re-inject them or reconnect them. Along the way, what I'm going to do is try to point out some traps that you might run into, some tips to help you reason through how to apply DI, and then some patterns that you might see that are common. I'm also going to try and touch on some connections between object-oriented design and functional programming that I think dependency injection makes apparent. And I'm also going to demonstrate the connection to some of the simple ideas in architecture like ports and adapters, hexagonal architectures. Sometimes you'll see people talk about clean or onion architectures as well. So here's the scenario. Suppose you operate some data pipeline that has a web scraper component, and that web scraper is scraping public news articles into a data archive that's stored up on S3. And then you have a team of data scientists who are going to consume whatever is in that archive for their NLP algorithms. Occasionally, you're going to index something that's not useful, like this list of stock quotes. So this is the top daily movers on a daily basis in the stock market. In straight form that just looks like this, you get a bunch of lines that are nothing but stock quotes, starting with stock ticker symbols. So the task here is write a script that scans your S3 archive to check for those bad stock quote articles. Right? What we're going to do is define an article as being bad if more than 50% of the lines are bad, and a line is bad if it just starts with a stock ticker symbol. I do have to explain some small things about how S3 works because you're going to see these terms in the code sample. So S3 is basically like a big key value store. It uses URIs for the key structure. Instead of a domain name, they have what's called a bucket. So the bucket name in this case is going to be PyBay 2019. The articles are stored in that bucket under keys, and the key structure is news/2.txt. Those keys have a prefix, which is how you organize your keys in that namespace. And then finally, buckets live in different data centers, which are organized by region. So these are just some details that you're going to see in the code sample. They're not terribly important. The other fact or other thing you have to know about using S3 is that you might have millions of items stored in a bucket. So if you want to actually scan those archives, what you're going to have to do is get a paginated list of keys, filtered by prefix, and then once you have each key, you can actually download the object. So now we can actually start looking at coding. Here's a really simple skeleton of what this code looks like. So we have the main entry point. We have this find bad articles function, and we're going to use the AWS Python SDK, which is Botto3. And there's some pseudocode that just describes that process of scanning the archive and checking articles. So we're going to get a paginated object list, iterate over each page for each key in each page, download the file, then you check the article to see if it's bad, and yield the key, and then just print it out to console. So the actual implementation of that also just looks like the pseudocode. So there's a get pages function, which uses the client, the bucket name, and the prefix. A keys from function, which parses the actual pages we get back from the page, from each page. Once you have the key, there's a get file function that downloads the file based on the bucket name and key and turns it into a bunch of lines. And then there's this check article logic, which is actually doing this business logic around checking for stock quotes, and then you yield a key. So here's those three functions that are interacting or working with Botto and the S3 data. This is just some details of how you use Amazon AWS. So in get file, you've got to create a buffer, download it, do some munging to turn it into a bunch of lines. Get pages, there's a pretty simple simple API for getting a page iterator that AWS provides. And then this keys from function, which is just parsing the contents of each page. Check article is also pretty straightforward. So given a bunch of lines and some threshold that you want to trigger as a bad article, plus a list of stock symbols, just iterate over the lines in an article, and then decrement a counter every time you find that a line starts with one of these stock symbols. And that's how you detect when this thing is bad. So that code is actually, it's pretty straightforward. In total, it's maybe 50 lines of code. And it's pretty easy to understand, but there's a couple problems with it. Right. First is that if you want to test this thing, you basically have to patch and mock, because the fact that it's using Botto is hard-coded in here, and it's scattered throughout the code. So basically, your test and your application are going to be coupled to details of S3 and this Botto SDK. The other thing is it's not necessarily that easy to change out the checking logic or the fact that S3 is the source of this archive. So it's very likely for something like this that you're going to want to change out the checking logic to filter for things or detect things like box scores from baseball games, which is also a pretty common thing that happens with news scrapers, is you get all these kinds of garbage articles. You're also probably going to want to do things like run your checker against a file system or run your checker against a tarball, for example. Right? So right now, that's not easy to do without making a lot of invasive changes. So what we want to do is try to decouple these concerns or extract these concerns and dependencies. So the first thing I want to look at is this idea of decoupling the checking concern by extracting that set of dependencies. And the way I want to do that is by making a hole in the middle. Right. So I've highlighted where I'm going to put that hole, which is I want to extract this check article logic. So instead of doing this, I'm going to add a predicate parameter and then inject my checking logic into the function. Right? So this is also another way of thinking about this is that I'm just turning this into a higher order function. As for injecting that logic, there's two ways we can do this. If I'm going to do it in an object-oriented style, what I'm going to do is define a policy class, which is called stock quotes check here. The actual implementation of the class looks like this. So in the constructor, I'm binding the configuration variables with this logic, and then I've basically just dumped the check article logic into this overloaded dunder call method, right? And that just makes it look like a callable. The other option here is to go with a more functional style. And instead of using a class and an object, you can go ahead and use a closure. So here I'm going to use this stock quotes closure to bind these two configuration variables, which is the threshold and stock symbols, with the check article function, and then inject that instead of using a class. So if I draw that as a dependency graph, it's going to look something like this. Find bad articles depends on a bunch of configuration variables, which you can see up on the left. Over on the right, it also depends on Bado3 client, and then it depends on all those utility functions that we wrote. So what we did with this hole in the middle pattern is to extract all the lines of code that were related to this concern of the checking logic, and then bound all those things together using either a policy class or a closure, and then inject them back into the function. Right, so that's a very simple version of dependency injection. So one of the things that people say when they first see this is, I think, is that dependency injection is just passing things in, and that's not quite true. It is true for very trivial examples. But for more complex scenarios, there's a little bit more to it, and this is a potential trap if you just assume that all it is passing things in. And to look at that, you need a counterexample, and there's one that's pretty handy, which is decoupling this archiving concern. So if dependency injection is just passing things in, what do you pass in here to decouple the fact that we're using S3, or decouple this archiving concern? Right? And it's not exactly obvious. So maybe you think, oh, well, I can just pass in the client. So that doesn't actually help you do anything. Right? It might remove one patch from your test. But the problem is that nothing has actually been decoupled. Right? So your tests still depend on knowing lots about Bado3 and S3 details. You're going to have to construct these patches and mocks. The other problem with thinking about dependency injection this way is that you've got to pass this client object all around your call graph. So you've got to pass it into get pages, get file. For a more complex call graph, it's going to get very tedious. The other thing to notice here, right, is that find bad articles does not actually use client. It's just constructing it so all these other functions can use it. Right? So in some sense, it's not actually a dependency. So one tip that I like to use is ask this question, does blank use blank? And if you fill that in here, does find bad articles use client? What you find out is the answer is no. It's not really a dependency, it's just getting passed around. Sometimes that's a sign there's a missing abstraction, which we'll get to. The other way to think about this is to remember that dependency injection is an idea that comes from object-oriented design. And in object-oriented design, you are thinking about code in terms of collaborating objects, or a graph of collaborating objects. So you want to think about dependency injection in terms of injecting direct collaborators instead of dependencies. So if you look at this, right, is client and direct collaborator find bad articles? Nope, it's not. So it's not something you really should be injecting. So hopefully that's going to debunk this idea that it's just passing things in. So now we can look at what it takes to decouple this archive concern. So if you look at this dependency graph, again, what I want to do is identify all the things that are going to change together if I want to swap out S3, or all the things that are related responsibilities. And that's all these things in this outline. So these are the things I want to extract and inject. So another tip is to think about encapsulation and information hiding. So you want to encapsulate and hide things that are likely to change simultaneously, things that represent a volatile concern, or things that are related responsibilities. Right? That's everything in this outline. So what we're going to do is extract all those things and then inject them, just like with the predicate function. The other thing to point out is that if I rewind to this, if you ever hear people throw around the phrase ports and adapters or hexagonal architectures, this is just a very simple example of that. So this is about 90% of what you need to understand ports and adapters. Another phrase you might hear people throw around talking about dependency injection or dependency inversion is that the details should depend on the abstractions. That can be a confusing phrase, but this is just a demonstration of that. So you have some abstract archive that S3 archive must fulfill or conform to. So the detail here depends on some abstract interface. That's also an example of dependency inversion. So just for the sake of completeness, you can also apply this same pattern to extracting the Bot03 client and injecting it like this. And I'll show that in code. So the things that are highlighted in yellow here are the items that were outlined. So I want to extract these responsibilities into a class, right, which is this S3 archive class. So we're going to reuse some of the utility functions we had earlier, add a constructor that binds configuration to this other logic, and then add a getKeys function, which takes the responsibility of both getting pages and parsing keys. Then in the main function and in the find bad articles function, we change the structure so that we're injecting it at the entry point. So I construct the archive and then pass it in as a parameter to find bad articles. I mentioned this uses trick, or this users relationship, and extracting the client, Bot03 client. So here's just another application of that. Does S3 archive use region name? Not really, it just needs it to construct a client. So you can extract that and inject that also. Right, so here I construct the client, inject it in the archive. When I construct it, then I take the archive, inject it into find bad articles, and I'm also injecting this is stock quotes closure into that function. Just another thing to point out, another pattern you might notice is if I take this dependency graph again and delete some unimportant details, right, this is representing the uses or the calls relationship between all these different entities that I've created. So find bad articles calls S3 archive, which calls Bot03 client, which uses config.region. The order I had to import or construct these things looks like this. So the construction order is different from the uses order or the call order. So that's also a very common pattern. They're usually different and oftentimes reversed. You can see that directly in code. So find bad articles here uses archive, archive uses the client, and the order I have to construct them in looks like this. So it's different and it's reversed. So that's just another tip. Your uses or call order is going to often be different from your constructed order, or it should be different from your constructed order. You should try to construct and inject your objects as early as possible in your application, and ideally around the application entry point. And sometimes you'll hear people call that the composition root. So I think there's one more improvement to decoupling, and this is going to take us into a fully functional implementation. So if you look at this and ask, is this decoupled from S3? Superficially, it is, because you don't necessarily have to use S3 with this archive. But I'm going to argue that it actually is, and the way to find that is to use this phrase instead of uses. So you can ask yourself, is find bad articles sensitive to the presence or absence of S3? So that's kind of the superpowered version of the uses question. And I'm going to say that yes, it is, because you can do this thought experiment where you ask, what if I want to use Kafka as my source archive instead of S3? If you use Kafka, that gives you tuples of key value pairs, right? And so what that's indicating is that this get keys and get file API is actually just an implementation artifact of using S3. So you could get rid of that pretty easily and turn this archive abstraction into just a stream of tuples by adding this small snippet of code. So you just iterate over the keys and you encapsulate this set of responsibilities. So you extract and place these in this thing that you're already injecting. What then happens is that find bad articles just becomes a pure function, basically. So if I want to unit test this, I can just use a dictionary for the archive. The predicate is already decoupled, and I can test that independently. And this code is only now 3 lines of code. I have all my concerns related to interacting with the archive separately that I don't necessarily need to unit test. Maybe I can just integration test that. I can unit test my article checking logic, and I can unit test this pretty easily. And this is so trivial that maybe you don't even need this function anymore. You just use iter tools or func tools to compose things together. So just to summarize, here's some tips about applying or trying to use dependency injection. Fundamentally, it's about decoupling and modularity. Right? You should try to think about injecting collaborators instead of dependencies. Sometimes thinking about dependencies or saying depends on can be kind of confusing. So collaborators can be helpful. Remember encapsulation and information hiding when you're trying to identify abstractions that you want to extract or inject. And then try to look for uses or presence or absence of relationships. That's also a useful trick when you're trying to figure out how to decouple things. And then just to reiterate some of the traps, fundamentally, dependency injection is not really about testing or test isolation. It's about modularity and decoupling. If you go on this path where you are trying to maximize test coverage or test isolation with dependency injection, you can run into a lot of problems. Same thing if you're thinking about dependency injection as nothing but passing things in. Here's just a couple of resources. Misko Hevery is the inventor of Angular, which relies heavily on dependency injection. So he has a bunch of good blog posts on DI techniques. Mark Seaman also wrote a book on dependency injection, and he talks about the connection between object-oriented programming and functional programming, if you're interested in that. And then earlier I mentioned that some people hate it, and if you go look at this blog post on Is TDD Dead, it's a conversation between Kent Beck and Martin Fowler and David Hansen, who's the creator of Rails, and he infamously says that dependency injection is not a virtue, and he hates it. So if you want to understand that debate, that's a good one to look at. So that's all I have now, and I think we have time for questions.
We do have time for about 5 minutes of questions if anybody has anything.
What does it mean for something to be a pure function?
So when something is a pure function, it doesn't have any side effects. So another way to think about that is to understand what it's going to do, you just have to look at the input and the code, and you know it's going to happen. or what it's going to produce. If it's impure, it might be reading the file system or accessing a global variable or something. So you can actually look at it and know what's going to happen just by inspection.
Yeah, hi. Great talk. Good introduction to dependency injection. One thing I was kind of like maybe confused by is that what I saw you doing is passing in dependencies, and you said it yourself that this is kind of like composition. You know, in a way, this is just good composition discipline from my point of view.
Right.
So what I'm wondering is, do you recommend any sort of like further prescriptive, have you seen any good dependency injection libraries or frameworks or use cases within Python? My favorite is PyTest, but I'll let you answer.
Yeah, so
yours.
PyTest uses dependency injection for fixtures. So if you compare that to the way the normal unit test framework works, unit test framework does it by overriding a base class. PyTest does it by dependency injection. In terms of other libraries, I started using Falcon framework, which also supports dependency injection, is kind of a first-class concept in their API design. So those are the two that come to mind. I can't really think of any other off the top of my head. Oh, okay.
Early in the talk, you referenced a term called patch and mock. What does that mean exactly?
Yes, so patching and mocking is basically a library provided by Python that lets you, so patch kind of lets you magically intercept function calls in your code and then inspect that behavior or modify that behavior. So it lets you simulate your dependencies. And then mocking is just a particular way of checking on what those calls are. So it's kind of a whole topic in and of itself. But I hope that makes sense.
Anyone else? Well, thank you, Edwin. I personally really enjoyed that. I'm not sure how was it, guys?